This video is on acid-base indicators. So when we're trying to determine what the pH of a solution is, there's a variety of different ways that we can do that. One of the ways and one of the most common ways is to use an acid-base indicator. These are really large organic molecules that work kind of like a dye. And when they come in contact with the hydrogen ions in an acid or base, they're going to kind of react. And the reason they react is that most of them are weak acids. And so there is this kind of reaction. And what it does is it changes the chromophore on on that molecule. And the chromophore is the part of the molecule that determines its color. And so one version has one color, and then the other version has a different color. So this is a very common way to determine the pH. It does have some limitations. You can only use this on clear substances. If a substance or a solution is already colored, we really can't use an indicator on that because we wouldn't be able to tell the color change. Some indicators only change color in acids. Some indicators only change color in bases. Some indicators are really good at indicating neutral pHs. So you just want to use the most appropriate indicator for what you happen to be looking for. Now, universal indicators indicate every pH level, and they're made by mixing several different indicators together. And so you have a different color for every pH level that we have, so 0 to 14. So here's an example of some indicators. There are a whole lot more, but these, if you mix these all together, you would end up with a universal indicator. They're all going to change color to a variety of different pHs. So this one here at the bottom would be a good one to distinguish like a pH of 0 from a pH of 1. So dealing with those sort of substances with a very low pH. While this indicator up here is really good for our high pH level, so distinguishing between a pH of 12 and a pH of 10. And then this one right here would be really good at distinguishing neutral solutions. So I have 4 different indicators that we're going to look at, and I have some solutions already put in there. You can kind of see them moving around there. And I have everything in this column is a pH of 1. Everything in this column is a pH of 3. This is 4, 7, 9, and 12. And what I'm going to do is I'm going to add different indicators so you can see what they do as you go across the pH scale. So the first one I'm going to use is methyl orange, and you can kind of see here that it is orange inside the bottle. But as I put this into my acids, you're going to see that they turn red. But in bases and in neutral, they stay that nice little orange, maybe even almost a light yellow color. All right, we'll just kind of move that around so it gets to be 1. So methyl orange is a really good indicator for those low pH levels. It's going to allow me to distinguish different types of acids. So whether it's a pH of 4 or a pH of 1 or a pH of 3. It's terrible for bases, though, because these 2 basic solutions look the same as a neutral solution. So you really would have no idea what the pH of the substance is if it were a base. All right, so the next one that I'm going to do is a very popular one, and it is phenolphthalein. So phenolphthalein is clear, and when you put it in acidic solutions, they stay clear. It's only when we get to very basic solutions that phenolphthalein changes color. So phenolphthalein's a really good indicator for those basic solutions, and you can distinguish a pH of 9 from a pH of 12 and on up. The next one is bromothalonil blue, and this one is blue in the bottle. And then as I put this into my solutions, for the acids, it's going to turn yellow. And in bases, it turns blue. So this one's a really good one, like if you didn't know an acid from a base and you wanted to be able to tell the difference. This one would tell you whether you had an acid or a base. Now, whether you had a pH of 4 or a pH of 1, it does not distinguish between those, nor does it distinguish between a pH of 9 or 12. But it does a really great job of distinguishing neutral solutions. So pH of 7 is that distinct green color. So oftentimes bromothiamyl blue is used to indicate used as an indicator for swimming pools. You take a sample of the water, and then you're going to add bromothiamyl blue to it. If it turns green, then you know you have a neutral solution, that your pool water is neutral and it would be safe to swim in. All right, and the next one is the universal indicator, and that's made by mixing several different indicators together so that it changes color at each pH range. Now, it's kind of red. It almost looks the same color in the bottle as methyl orange, but you can see that it changes color. It's a different color in every pH scale. So if you just needed to know the pH and you had no idea whether it was an acid or a base, and you had access to the universal indicator, that would be a good one to use. As long as you had some sort of scale to go by, you could figure out what the pH is. But this just makes a very beautiful little set of solutions there. Now, you may be familiar with universal indicator if you've ever used pH paper. pH paper is just paper that has universal indicator soaked into it, and you would have expose this to a chemical, and then you can kind of judge what color it is. So I have some ammonia over here, and I'm going to try and show you, because ammonia is pretty cool because it does evaporate so easily. It is a volatile liquid here, and so I think you'll be able to see it. Here's my open bottle of ammonia and my pH paper. I'm just going to set it on top, and you can kind of see the vapors make the pH paper change color. If I actually expose it to the chemical itself, then we could kind of see and judge. Oops, let me pull this back down. We can kind of judge and see what color it is. This looks like it's right around a pH of 9, and that would be about what we'd expect for household ammonia there for cleaner. All right. So that's acid-base indicators and an easy way to tell the pH of different substances.